This video, we're going to talk about the definite integral as area. And so we're going to start with this example here. It says, let f of x equals 2x. On the coordinate axis below, draw the graph of f of x and shade in the area made between f of x and the x-axis from x equals -1 to x equals 2. All right, and so we already have the graph drawn. We just have to shade in the area between the x-axis and x equals and the function from x equals -1. So x equals -1 is here. I'm going to use a different color. So x equals -1 is here. And the area between the x-axis and this function is this little triangle here. And then from 0 to 2, we get this triangle here. So these are the areas. This is the area between the x-axis and the actual function. All right. And so it says use the left hand and right hand sums with 3 rectangles to estimate the integral from -1 to 2, right? Again, -1 was here. We got 0 here, 1 is here, and 2 is here. So we're going to do a left hand sum and a right hand sum to estimate that, right? So the integral from -1 to 2 of f of x dx is approximately the sum from I equals 0, n equals, this is our n equals 3. So n minus 1, which is 2, f of x of I times delta x. Now, if we're going to use our Riemann sums, we start at -1. We're going to go to 2. Our delta x is going to equal b minus 8, which is 2 minus a -1 over our n, which is 3. We get 1, right? And so if we're going to use 3 rectangles, -1 to 0, 0 to 1, and then 1 to 2. I drew this one a little big, but that's fine. And so our left-hand sum is going to be coming from doing delta x. This is x sub 0, x sub 1, x sub 2, and x sub 3 times f of 0, right? Because we start at I equals 0, so it would be f of -1 plus f of 0 plus f of 1. And that's going to give us our 3 rectangles. Again, our delta x was 1. F of -1, we go to our function, find our y coordinate, which is -2. F of 0, go to our function, find our y coordinate, so that's a -2. We got a 0 for our y coordinate here, which is 0. And at f of 1, our y coordinate is nice, it's 2. And so when we do this, 1 times this quantity, that actually equals 0. Now we're going to do our right-hand sum with those 3 triangles. So this integral is going to be approximately equal to the sum from I equals 1 to 3 of f of x of I times delta x. All right, the x of i's are the same. Our delta x is the same. And so my x sub 1 is 0. So I'm going to do f of 0 now plus f of 1 plus f of 2. I go to my function, find out what f of 0 is. We already found that that was 0. F of 1, we already found that that was 2. And now we have to find f of 2. At 2, my function takes on the value 4. And so I'm going to have 4 there. I add those together, I'm going to get 6. A better estimate would be to do the 0 plus the 6 divided by 2. So my estimate for this integral is 3 units. All right. Now I get 3 units here. That's the estimate for this integral here using my left and right hand sums and doing the average. Part B says find the total area between the x-axis and f of x using the geometric formulas for the shape. Well, if I look here, this shape right here is a triangle, right? So this is a shape, this is a triangle, right? The area of the triangle equals 1/2 the base times the height. This shape right here is another triangle, and it's going to be 1/2 the base times the height. The base is always drawn perpendicular from the height. And that looks like 2 bases. That's a height, okay? And so it's going to be area of triangle 1 plus area of triangle 2. The area of triangle 1 is going to be 1/2. So my total area equals that, which is going to be 1/2. I'm going to go back to my picture. My base is, let's say, 1, and my height is 2 units. So it's going to be a 1 times 2 plus a 1/2. My base for that second triangle is 2 units, and the height is 4 units. And so I'm going to get 1/2. 1 times 2 is 2, and half of that is 1. That's 8 divided by 2, which is 4. And so my area is 5, right? So that'll be 5 square units. And so when I did this, right, what I've seen here is that when I do my total area between my x-axis and my curve, I get this exact estimate, right? Or this is the exact value. It's no longer an estimate because it's area of triangles. But when I do my left and right hand sums, I get a severely low estimate of this area, right? And so one of the things that I wanted to talk about is what's the difference between the answers in parts A and parts B and part B. What happens when we do our left and right hand sums is that we consider the y values of the function when we're calculating that area, especially, and this is especially important when part of our graph is below our x-axis or part of our function has negative y values, right? Notice when we did our left-hand sum over here, we took the area of this rectangle here, all right, to represent this area from -1 to 0, right? Because this has a y value of -2. So notice I multiply that 1, which is the width of this rectangle, by -2. And that gave me this area here. Well, we know that area does not equal a negative value ever, right? And then from 0 to 1, we use this because at 0, our left-hand sum is this. We don't have any area at all there, right? And then when I do my rectangle that represents the interval from 1 to 2, I use this rectangle here, which is good and fine. But notice here, when I add these two things together, I got 0 when I did my left-hand sum. It is because our integral, our right-hand and our left-hand sums, takes the y values into consideration. And so what the difference between the answers in parts A and B lie in the fact that this left and right hand sum stuff, this integration stuff, it makes things below the x-axis negative. Now we know that our total distance is the area under the curve. If we want a total area or the total area between our x-axis and our function, we know that area can't be negative. And so what we do in this part B here is we basically made all of the areas that were below our x-axis, we made them positive. Notice here, if I were to make this part negative, I get -1 plus 4, which is 3. And I get the same answer that I get in part A. And again, the reason for that is because when I think about geometric area, it is never negative, and so we make everything positive. But this integration stuff, this left and right hand sum stuff, is going to make areas under your x-axis negative, and it's going to make that keep the areas above your x-axis positive. And so what's the difference between parts A and parts B? Part A makes areas below the x-axis negative because it uses the actual y values or function values of the function. Part B uses the geometric concept of area and makes, I don't need a comma there, and makes each area positive. And so there are two things that we have to consider here. We want to consider if we need the total area between the function and the x-axis, or if we want just the integral. The integral is always going to give you the total change if your function is your rate of change and your x-axis has the units that it's changing by, right? But if we want to know the total area between the x-axis and the function, we got to make that negative area that's below the x-axis positive in order to get us the total area, okay? And so in this statement here, it says when f of x is positive for some values of x, that means above the x-axis, and negative for other values of x, that means below, then the integral of f of x dx, okay, let's do this here, is equal to the area above the x-axis minus the area below the x-axis. All right, and I'm gonna be specific and I'm gonna say the geometric, all right? Because geometric area we always assume is positive, okay? So it's the geometric area above the x-axis minus, it's going to make the area below negative. And so instead of adding, I'm going to say adding a negative, I'm going to say minus the geometric area below the x-axis. And so we just want to get used to this stuff here, right? And so in this example here, I want to determine whether each statement is positive or negative. For instance, the integral from a to b of f of x dx. This is our function f of x. I want the integral from a to b. Well, my function is completely above the x-axis, and so this area, the answer to this one is going to be positive. From b to c, right? Notice we always go from below to low to high, right? The integral from b to c. The integral from b to c is completely below the x-axis, and so that is going to be a negative integral. It's going to make that area negative because all of our y values, when we do our rectangles, are going to be a negative value if we were to use our left and right hand sums. The integral from c to e of f of x dx, well, that's completely above the x-axis, and so that will be a positive value. And then we have the integral from a to e. Well, a all the way to e has some parts above the x-axis and some parts below. Well, we have to kind of quantify or compare the area above the x-axis to the area below the x-axis, right? So this area is above the x-axis. So those are going to be positive, and these areas are going to be below the x-axis, which is going to be negative. There is actually more area above the x-axis than below the x-axis, and so we can say that this is going to be positive. In this example, we're going to find the exact area, the exact value of the integral from -3 to 7 of f of x dx, where this a2 represents the geometric area of this space here. So it's saying that this area here is 5.6 square units. And it's saying that this area here under the curve between my x-axis and that value is 12.5 square units, right? And so if I wanted to find out what this integral is, I'm going to take the area that's below the x-axis and make it negative. So that's going to be a negative 5.6. And I'm going to add to that the area above the x-axis. We're going to make that positive or keep that positive because it is above. And if I add those together, we're going to get 6.9. So the integral makes the whatever area is below negative and makes whatever area is above positive, right? So negative 5.6 plus 12.5 will give us that 6.9. Example 3 says find the total area between f of x and the x-axis. Well, the total area is just the combined positive areas, right? So notice the difference between what it's asking. When it's asking for the integral, we make the whatever values below the x-axis negative, and if it's asking for the total area, we keep all of the areas positive, and we get 18.1, okay? Last but not least, we're going to look at this example here. We have the integral from -3 to 5 of f of x dx. Again, when I'm given a geometric figure and I have to figure these things out, I'm going to use my left and right hand sums to help me find f of x, the integral of f of x dx, right? So I'm going to start with my left hand sum, and I'm going to go, remember, sigma notation, I equals 0 to n minus 1. Well, when I'm given a graph like this, I'm going to use all of my values that are labeled, right? That are ticked off, right? So I start at -3, which is this endpoint, and I'm going to go to 5, and I'm counting by 1. So I have 1, 2, 3, 4, 5, 6, 7, 8 subintervals there. So I'm going to use n equals 8. All right, and so since my left-hand sum goes from I equals 0 to n minus 1, that's going to go to 7 of f of x of I times delta x. My delta x here is b minus a over n. It's basically the numbers that I was counting by, which was 1. But if you want to use your a and b, my b is 5, my a is -3, and my n was 8. So my delta x is 1. And if I want to know my x of i's, I start with my leftmost endpoint. I have my other endpoint, and I'm going to write 1, 2, 3, 4, 5, my 8 subintervals. and they're 1 unit in length. And so I'm going to have -2, -1, 0, 1, 2, 3, 4, 5. So I get my x of 0, x of 1, x of 2, x of 3, x of 4, so on and so forth. And so if I want to estimate this, I'm going to multiply my delta x, which we have out front, times f of x of 0, which is -3, f of -2, f of -1, f of 0, f of 1, f of 2, f of 3, f of 4. My delta x is 1, so I'm going to have 1, and I have to find my y values, these functional values here, by looking at my graph. So I'm going to go ahead and find my y values. This point has a y value of 0. At -2, it looks like it has a y value of 7. Here, let's say 6, 0. That looks like it's about 8. That'd be a -8 though. Here, let's do -15, -17. I'm going to do another -15, and then we're going to do a 0, right? So when I do my left-hand sum, I take my functional value at -3, which is 0, functional value at -2, which is 7, at -1, 6, at 0, we get 0, at 1, we get -8, at 2, we get -15, at 3, we get -17, and at 4, we get -15. And I left off my plus sign there, plus. All right, we add those together. I'm going to put that into my calculator and multiply by 1. Well, you don't have to necessarily multiply by 1. Okay, and I get -42. If I do my right-hand sum, I'm just going to do this part where I'm not going to write all this out to save us some time. But when we do this, sum I equals 1 to now 8 of f of x of I times delta x. And that's going to be a 1 times a 7 plus 6 plus 0 plus a -8 plus a -15 plus a -17 plus a -15 plus a 0, right? Because we're leaving off this endpoint and adding on that endpoint, which is going to give us the same values. And just so that I can check myself again, I'm going to redo this calculation. Uh-oh. And again, we get that -42, which is the same value that we got here, because each of our endpoints were 0, or they were the same in value. So my starting endpoint with my left-hand sum was 0. My ending endpoint with my right-hand sum was 0. So we got the same value. And so my estimate of this integral, -3 to 5 f of x dx equals -42. And so basically the goal of this section was to point out that when you have part of your graph under the x-axis, your area that is estimated using your left and right hand sums or using your integral is going to be negative, all right? And it's going to keep whatever above the x-axis positive. That is the goal of this section. If you want the integral, keep the stuff below the x-axis negative. It's automatically going to do that when you do your integral in your calculator. But if you want the total area, you have to consider, like in this example, what's above and what's below, and make what's below negative. Positive when you're doing the total area. All right, that's all for this video. We'll see you during the next one.